Well, welcome to this conversation about laws of exponents, and we're going to do a little bit with scientific notation in this one as well. So first, we're going to start by reviewing the laws of exponents and how they can be applied. So let's jump into that. Okay, so the very first law of exponent we're going to be talking about is the product rule. And the product rule looks like this. If I have an exponential expression with a base raised to the m power, and I multiply that by a base raised to the n power, well, I end up with the base raised to the m plus n power. Okay, now some of you may be thinking, why does it work that way? So I want to show you, because if you understand why it works that way, then you will remember, okay? Let's say that I have, b to the third, b cubed times b to the fifth, all right? That's really shorthand for b times 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 b, right? This is b cubed and this is b to the fifth. Well, if I count up all these b's, I have b to the eighth, which is 3 plus 5, right? 3 of them here and 5 of them there. Okay, so if the bases are the same and we're multiplying those exponential expressions together, we just add the exponents. Okay, so here we have 2 cubed times 2 to the fifth. And so we can say that that's the same as 2 to the 3 plus 5 or 2 to the 8. And then we could evaluate that to be 256. Now, if I have something that looks like this, we have two exponential expressions that are a little more complicated. You're just going to multiply together the things that kind of match. So we're going to group those things together. Notice I'm grouping the coefficients 4 times 10. Then I'm going to group the x's, x cubed times x squared. And then I'm going to group the y's, y to the fourth times y to the sixth. All right. So now I'm going to go ahead and simplify this. 4 times 10 is 40. X cubed times x squared is x to the fifth. And y to the fourth times y to the sixth is y to the 10th. Okay, so there's the product rule. The quotient rule is similar, okay? And instead of multiplying here, we are dividing. And again, I'm going to show you why this works in just a second. If I have the same base in the numerator and the denominator raised to different exponents, then we can say that that will simplify to that same base raised to the m minus n power, where m is the power in the numerator and n is the power in the denominator. Okay, so let's take a look at this. Let's say that we have an expression b to the fifth divided by b cubed. So let's look at what that really is shorthand for. That really is just a shortened way of saying b times b times b times b times b on the top divided by b times b times b on the bottom. Well, whenever we see the same numerator and denominator, that's a form of 1. So we can divide each of those pairs out. B divided by b is 1. B divided by b is 1. B divided by b is 1. And so all of those virtually disappear. And we're just left with the two b's in the numerator that are left. So we just end up with b squared, which is 5 minus 3. Really what you can say is every match is going to cancel out. So if you've got 3 in the bottom, 3 of those of the 5 on the top are going to cancel each other out. Okay, so let's look at this example then. Negative 3 raised to the 6th times negative 3 squared. Well, that's the same as negative 3 raised to the 6 minus 2, or negative 3 raised to the 4th. So that means I'm taking negative 3 and multiplying it by itself 4 times. Negative 3 times negative 3 times negative 3 times negative 3. And we should end up with a positive 81 there. Now, it's really important to note the notation here. Okay, so when I'm looking at this, this negative 3 raised to the fourth power, what that really means is negative 3 times negative 3 times negative 3 times negative 3. That's different than negative 3 to the fourth, which is negative 3 times 3 times 3 times 3. And we would end up with a negative value with that one. Okay, so be careful. And if you're using your calculator, just make sure that you're using it appropriately. Okay, let's look at this next example. 27x to the 14th y to the 8th divided by 3x cubed y to the 5th. This is similar to the problem that we did with the product rule where we just separated the pieces that corresponded to each other. 27 divided by 3, x to the 14th divided by x cubed, and y to the 8th divided by y to the 5th. If I simplify all those things, I get 9, x to the 14 minus 3, and y to the 8 minus 5, which will end up being 9, x to the 11th, y cubed. Right, the next rule or next law that we want to talk about are the exponents of 0. So let's go back to our thought about the quotient rule, right? We're going to look at a quotient here. Here I have b to the m over b to the m. Well, if I apply the quotient rule to that, that means I get b to the m minus m, which is b to the 0. But we just got done talking about the fact that if I have the same thing in the numerator and the denominator, that is the same as 1. What that means is anytime I have any base raised to the 0 power, the output will always be 1. Okay, it doesn't matter what the base is. So in this case, we have 17 to the 0 power, which is 1. In this case, I have negative 192,946, all raised to the 0 power, which is 1. In this case, a little tricky, be careful. I have 12 times 142,694,217 raised to the 0 power. Well, what's raised to the 0 power here? Just this part, right? So this part is 1, and then I'm multiplying that by 12, so I end up with an output of 12. The next law that we're going to talk about will be negative exponents. Okay, so we're going to start with an exponential expression that looks like this. 1 over b to the m. We just said that 1 is equal to b to the 0. So I just replaced 1 with b to the 0 here. Well, using our quotient rule, I can say that this is b to the 0 minus m, which is b to the negative 1. I'm sorry, which is b to the negative m. Well, notice all of these are equivalent, and that means I can say that b to the negative m is the same as 1 over b to the positive m. Okay? So when I have a negative exponent, I can take that base, put it in the denominator, and make the exponent positive. Okay, let's apply that here. 5 to the negative 2, that will be 1 over 5 squared, which is the same as 1 over 25. Negative 3 raised to the negative 3 power, that's going to be 1 over negative 3 to the third, which is 1 over negative 27, which is negative 1 over 27. If I have a negative in either the numerator or the denominator, then it's going to make just a whole fraction negative. Oh, here's one. Ooh, this is a little tricky. I have a negative exponent, but it's in the denominator. Okay, well, no worries. I'm just going to think about this separately. This is 1 over 4 squared, right? But this 1 is on top of it. So I've got this 1 on top, and then I've got 1 over 4 squared. So what this is saying is, it looks complicated, and in fact it's called a complex fraction because it's a fraction within a fraction. This is saying 1 divided by 1 divided by 4 squared. In other words, we can say 1 divided by 1 over 16. Well, remember that when you divide by a fraction, it is the same as multiplying by its reciprocal. So this is the same as 1 times 16 over 1, which will give us 16. Okay, in this one, notice that I have only one thing that has a negative exponent. This x has a negative power. It's raised to the negative 6th power. So I'm going to take that and push it to the denominator, making it positive, but just that piece. Okay, so that piece will become 1 over x to the 6th, and then when I put it all together, I will end up with 3y to the 4th x to the 6th. All right, next we have a power of a power. All right. Now this is easy to confuse with the product rule, okay? But this is a power raised to a power. So for example, I have b raised to the m, and that whole thing is raised to another power. Well, when we have that, it's a little bit different, and we just multiply the exponents. And so this we could say 3 cubed raised to the 2nd power is 3 to the 3 times 2, or 3 to the 6th, and we could evaluate that to be 729. Y to the 7th power raised to the negative 2 power, well, that will be y to the 7 times negative 2, which is y to the negative 14. And that negative exponent we can make positive by pushing it to the denominator, 1 over y to the 14th power. Here I've got c to the negative 2 raised to the negative 3. We can say that this is the same as c to the negative 2 times negative 3, which is also known as c to the 6th power. All right, we're close to being done here. We got 2 more. We got the power of a product and the power of a quotient. Okay, so the power of a product. This is a great tool to have. If I have a product, and remember, a product is the answer of a multiplication problem. So here I have 2 things being multiplied together. This is the only time that this rule works, the power of a product. Okay? What that means is I can apply this exponent to both factors, or if there's more than 2 factors, to all factors. So in other words, this is the same as a raised to the m times b raised to the m. Okay, so remember that this power will have to apply to everything that's being multiplied together. So if I'm looking at this example, I've got negative 4x, and that whole thing is raised to the 4th. Well, that 4th power will be applied to the negative 4 and also to the x. So it will look like this. Negative 4 to the 4th times x to the 4th. Okay, well, negative 4 to the 4th is positive 256 times x to the 4th. Okay, for this example, 2 times x cubed times y to the 5th, all raised to the 4th power. I'm going to need to apply this 4th power to the 2, to the x cubed, and to the y to the 5th. So it kind of looks like this. 2 to the 4th, x cubed to the 4th, y to the 5th to the 4th. And then we will simplify. 2 to the 4th is 16, x to the 3rd raised to the 4th is x to the 12th, and y to the 5th to the 4th is y to the 20th. All right, last law or last rule, which is power of a quotient. Very similar to power of a product. So this is when you have a quotient, it will be one expression where something is divided by something else, and that is all raised to the m power. Well, I can divide that up, and say that that's a to the m divided by b to the m. So I can just apply this exponent to both the numerator and the denominator. Okay, so let's look at how we would apply that here. Okay, I've got negative 2 over y, and that's all raised to the 5th power. Now when I have a negative as part of a fraction, I want to assign that negative to either the numerator or the denominator. Okay, and I always just assign it to the numerator, but I can't assign it to both because remember that if you divide a negative by a negative, you end up with a positive value. Okay, so I'm going to just assign that to the numerator. Now I have negative 2 over y, and I can raise that to the fifth power by applying that 5, that fifth power, to both the numerator and the denominator. So I've got negative 2 to the fifth divided by y to the fifth. So if I take negative 2 to the fifth, I'll get negative 32 over y to the fifth, and then I'll take that negative and just apply it to the entire fraction. All right, last example here, x to the fifth divided by 3, all raised to the third power. X to the fifth to the third over 3 to the third. So that would be x to the 5 times 3, x to the 15th, and 3 to the third is 27. All right, in the next video, we're going to put all the rules together and learn what it means to simplify exponential expressions. I'll see you then.